welcome again to sunny Ireland, and we're standing at another outcrop here. In this case things look a little bit different from what we've looked at before. We're standing at a location called Gull Island, aptly named after the little island with the gulls on it, and hence the stratigraphy we're looking here is called the Gull Island formation. But before we get into some of the what we think this is, my colleague Brandon here will kind of lead us through a few basic observations, and then I'll try to kind of wrap that together into what it all means.
All right, so this is a little bit different than what we've seen before in some of the other places, but at the same time there are some similarities, especially starting at the bottom. If we look and start and just make observations towards where the water is, we can see long, thin, continuous beds, fairly recessive, darker in color, probably not particularly coarse grained, probably fine grained muds or silts. You also have some beds up there as you go a little higher up that are a bit less recessive, but again, it doesn't look to be much coarser in grain size than what we see down there. So fairly recessive, probably very small grain size at the bottom, but very long, continuous beds that go from one end of the outcrop all the way to the other. There may be some slight variations in thickness, but in general, very continuous. As we start to move up, we start to see some other observations. We can see some units that are a bit more homogeneous, don't have that internal bedding. Especially as we get even higher up, it starts getting even a bit more deformed within some of this, especially in this middle area. So a lot of deformed area sediments there. We can see some really hard units that are this kind of just darker brown color within that kind of look like they're floating, like almost like little lozenges of something in there that's probably a lot harder. That might be coarser grain, perhaps that could be a sand. We see some of those that may be on the sides as well. You do see some thin bedding that continues off to the side, to the left in places, but you also see a lot more of these bands of homogeneous sediment as you go up. You get up a little higher, you might get a little bit more bedding, but in general we're starting to see a lot less of these long, continuous, thin beds and a lot more uniform looking sediments.
Yeah, no, very good. So if you come here, and obviously you'll be able to see a lot more detail than what you can get from this video, and we got some awesome drone footage as well. But you know, a key thing here is to, as Brandon has done, just sketch the observations almost in terms of same way you would do with seismic facies, but here with kind of outcrop facies. So there's basically three kinds of outcrop facies. There's these thinly bedded, recessive, well, you know, based on the calibrating our eye, probably quite muddy units. Those are little gravity flow deposits of mud. Now the big question always with that is, are those really dilute or distal gravity flows, muddy turbidites, or could they be contourites? Could it be mud transported on the seafloor by contour currents? And it could be either in this case. One thing that's kind of interesting with that facies that we do see in here a little bit is you see some really kind of long waveform, kind of wavy laminations in there. And if you think about seismic data in these settings, these might actually be very long waveform antidunes that you typically get developed in there. So that is kind of that facies. And then the slightly more resistant but still pretty muddy beds, kind of here shown in the blue colors, are, if you calibrate those and you go there, they're debris flow deposits. So they're very poorly sorted, muddy matrix, but they still have sand grains inside of them that are floating in there. So they're muddy debris flows. And then the key one that always gets people attracted to this outcrop and drawing straight in are these deformed bodies. And there are these buff colored sandstones that are deformed inside of there, and you can actually trace some surfaces that come down and climb up and that are cutting down into that. So those packages we interpret to be slumps. So those are actually true mass wasted deposits inside of there. So what you get in this whole cliff is a stack of muddy turbidites or contourites with these slumps and with debris flows. And what's really interesting, you know, you see one of these these slump deposits coming through here. It scours into and cuts out quite a bit of stratigraphy on the left hand side, and then it actually leaves a little bit of topography behind, so you can actually see some of the debris flows and the muddy contorites kind of thinning as you come up to the edge of that. So that's what you're looking at here, probably about 30 meters in height here, a couple hundred meters in length, so it's kind of a maybe 3 times vertically exaggerated the way I've drawn it here. But this kind of stack of mostly muddy deposits but different kinds of facies is really common in slopes, whether they are true passive margin slopes or smaller scale slopes in smaller basins. This kind of motif is what you get in there. And on seismic data, if you see this kind of stack, it very often has that seismic facies that we call MTC, or mass transport complex. So it's a seismic facies term for discontinuous seismic reflection packages that are being interpreted to be mass waste. The key is, when you look at something like this in outcrop or even in core or even in well log, it's very rarely just one big mass waste. It's actually composed of a whole bunch of mass wastes, but also with intervening debris flow deposits, and as well intervening times where constructional slope is being formed, probably by contour current deposits. So just be careful when you look at that. So, you know, why do we care? Now, when you see a package like that on seismic, you might just call it one thing, but you'll actually find that as you drill through that, even though it's all muddy, you get really big changes in acoustic impedance. Particularly debris flows in the slumps here are very hard, whereas some of these muddy debrites and contorites are very soft. You can get very big variations in impedance structure in here. You can get some real strong amplitudes inside of these MTCs, and that's mostly just mud on mud type of setting. So I think this is one of the best outcrop localities as an analog for discussing seismic scale facies for mass transport complexes. So lost the sun, so we'll call it good on this one.
Yep.
Oh, look at the fish and the bird though.
There's the bird and there's the fish,
and
just
the
in case, and the car for scale.
Love it.